Good morning, everyone, and welcome to the TRINITY Robotics for Industry 4.0 seminar. My name is Jyrki Latokartono. I work as the project manager in TRINITY at Tampere University, who is coordinating this action. Also, other TRINITY partners are joining this webinar, as well as our coordinator, Professor Minna Lantz. So, we will record this webinar as being instructed, and this will be placed on our YouTube channel for further use. If you don't wish to be included in the recording, mainly this applies for the discussion and questions, please let me know so we will edit you out from the final recording. And during the presentations, please mute your mic. If you have questions, place those into the chat window, and then we will discuss those after these presentations. And then during the discussion time, please raise your hand in Teams so we can give you the mic when needed. TRINITY is a Horizon 2020 funded project where our objective is to build a digital innovation hub focusing on agile manufacturing. There are other sister projects in different areas of robotics. TIH Square and TRINITY are the ones that focus on manufacturing. So the main goal is to improve the agility and the innovation potential of the European SMEs. During the project, we will build a digital innovation hub, a network that can support the SMEs in manufacturing after the project. And part of this network building and creating new ideas, we are having external companies, so-called external demonstrators, which of 5 will be presented today in today's webinar. TRINITY Consortium consists of 16 partners from 10 different European countries. We have research organization, we have small and big companies, and then other players who can support the goals of TRINITY project. And as said, the agile production is our key focus, and we look at it from 3 different points of view, if you like: robotics, cybersecurity, and Internet of Things related technologies. So these are kind of like the cornerstones of TRINITY. And today's presentation and today's webinar focuses mostly on this Internet of Things issues, which that can provide, or what that can provide for the SMEs to work on improving the agility of their manufacturing processes. TRINITY concept and approach is quite pragmatic, so we bring examples how to improve the agility. These examples, so-called internal use cases and demonstrators, they are something that has been developed in previous EU projects. So technologies that we believe could improve the agility, but might need some rework and polishing to make them in such form that the SMEs can use them. Because what we do in academy is not always even nearly the same as what is needed and done in the industry. So now we are trying to create these modules, and the idea is to provide a set of building blocks where the companies can pick up the best technologies for their needs and then start using those in their own production and then improving their production agility and other robotics related topics. And the external demonstrations where we have funded what we have funded in this open call and in this first demonstration program, they are also building these kind of modules and blocks where we can then create new possibilities and new support for the companies in the future. TRINITY Demonstration Program 1 started some months ago, and we got 115 applications, which is quite a large number. Applications came from the 27 different countries, in EU and connected countries nearby. And there were nearly 300 companies involved in these applications. So we covered quite a good, quite a good coverage around Europe. And also the evaluators were interested in our work. So basically we used external evaluators who evaluated all these applications and saw, is there a potential for these goals that Trinity is aiming for? And out of those, we selected 19 proposals for funding. There are 44 companies and research institutions involved in these 19 demonstrations that are now running. They are coming from 14 different countries, and the total budget we are allocating them is 4.66 million euros. So we expect to get some quite nice results with this support. And this started in July 2020, and now we are hearing sort of the first of these demonstrations. To improve the communication between the SMEs and the academia, we have also assigned each of these consortiums Trinity assigned mentor who will be supporting them in their work, because we have a lot of companies who are first time involved in European projects, so they might need help with the bureaucracy, although we are trying to make it easier for them, but also other aspects of work. And I think this has already proven quite a good choice, because we got good communication, and hopefully we find new ideas also for the future, not only during this Trinity demonstration program. We will also have a second open call, and the timeline will be published soon, so that will be next year. Similar as the first open call for the demonstration program, but this time we are looking slightly shorter demonstrations, and then the funding per demonstration will be a bit smaller than in the first round. And we try to improve the European dimension so that we require multinational consortiums in the next open call. But for that, please follow our channels for more information about the coming open call. But let's now move to the actual topic of today's webinar, which is the Robotics for Industry 4.0 and the IoT, other easy programming technologies that are being investigated with these consortiums that we'll be presenting today. So here is the tentative timeline, and we have 5 minutes speech from each of these consortiums. After that, there will be 10 minutes for the questions and discussions. So I hope you actively take part in this, and we can find new connections and new contacts. Unfortunately, we cannot offer you any coffee break or beer after the webinar, but maybe that time will also come after all these COVID issues have been solved. But for now, let's start with today's program. So the first one presenting is Sara Mata. She's a researcher at Ideko, and they are part of the ARGRIND consortium, which is working on improving the robotized grinding, which is quite a challenging process and has a lot of parameters that to be adjusted and a lot of other issues involved. But I give the screen to Sara to explain what they have come up with in ARGRIND project. Welcome. Your mic, Sara, is still muted, but we can see
yes, sorry.
Okay, no problem. Go ahead.
Good morning. Okay, our demonstration is entitled Advanced Robotics for Accurate Grinding of Complex Metal Parts, and we aim at performing a full grinding process of a complex metal part from the aerospace sector with our robotic solution. The consortium is formed by AGRIND, which is a Spanish SME, specialized in the development of and commercialization of robotic and industrial automation solutions for the manufacturing industry. Motorworks, a German SME, which is one of the global leaders in simulation software development to enhance CAM software, and Ideko, a Spanish research center specialized in advanced manufacturing technologies. Okay, first, which is the problem, which is to grind a complex metal part. Grinding regularly current metal parts subjected to grinding operations to smooth out imperfections, provide regular surfaces, or bring the parts into correct final geometric tolerances. However, this task has been traditionally been made manually by a skilled operator, but luckily nowadays robotics is taking these operations, but these solutions are mainly focused for simple parts, and complex metal parts are still a challenge. We say a complex metal part. We say that a complex metal part is the one that has a complex geometry with a lot of curvatures, and that requires long operations to remove high quantity of material, and it has a strict finished part requirements. So these operations are still a real challenge. So we propose a solution that includes several features that will allow to complete this process. So we count with an industrial robot with a grinding tool. This tool is with belt abrasives to increase the flexibility, and has a compliant motion to also allow more flexibility. The robot includes an embedded toolware control for homogeneous material removal on the part. This control will allow to constant material removal capability and guarantee a smooth surface. We also include automatic material capability characterization system to fit that control. The robotic solution also will include a companion ground surface simulation software for fast programming of new parts that will allow during the definition of the trajectories of the robot with CAM software to simulate which is the ground surface and adapt the trajectories to increase the result. The solution also includes a grinding strategy management system to perform the management of the different robot programs and the control. The solution also includes will include an automatic, safe, collision-free tool changing and calibration station, and also an online robot and process monitoring system for production traceability. Oh, the video. Okay. And in this demonstration, our goals will be to perform a full grinding process in a complex metal part, which will be from the aerospace industry. We want to guarantee a smooth surface, and we will guarantee the tolerances less than 0.1 millimeters. We want to complete the programming and simulation in 8 hours, the programming of all the trajectories of a part, and with the simulation with the software, we will guarantee that after the grinding process, the part will have no damage. We don't want to generate any scrap part, because these parts are really expensive, and it will be really positive for the And we also will have a monitoring data acquisition system, and we will see in online, we'll capture data every 1 second from the process and from the robot. And that's all. Thank you for your attention. If you have any questions.
Thank you very much, Sara. We have some questions in the chat. Okay, that was more of a comment on a similar application. You promised 0.1 millimeter accuracy for the surface, and surely the robot accuracy is not good enough to provide that. So how do you ensure this quite high number?
The accuracy is in the part. We will remove material, and we will guarantee that we are not going to remove more material than required. And we will achieve that thanks to our homogeneous material removal control. That we will continuously, we will guarantee that we will remove the same quantity of material in each pass, and we are going to control how much material we are removing.
Okay. Do you also measure the part during the process, or are you mostly relying on the constant removal rate?
It's going to be based on the thanks to the material removal control. We are not going to measure during the process. Okay, that's quite a high promise. So I hope I think it's a good technology. So it sounds very promising for this high accuracy grinding and polishing requirements. Thank you. Any other questions, comments to Sara? Okay, if no other comments, you can of course always contact Sara later, or you can also contact Ibai Inziarte, who is the coordinator of this ARGRIND action. So his contacts you see on this slide, and also there is some links where you find more information on these companies and the applications. And there will be links also from the Trinity web pages for more information on this topic, as well as the other demonstrations. But if no other questions, we can move to the next presentation. So thank you very much, Sara, for your presentation. The next demonstration presented is SNIPE, which is presented by Manuel Lobati. And just a second, I will bring the one page of SNIPE. So basically, this is a demonstration from the IoT side of Trinity activities. And this consortium is working on a sensor network that can be used in predictive maintenance. So Manuel, you're welcome to present your progress so far.
Thank you very much, and good morning to everyone. I try to share my screen. Okay. So SNIPE, first of all, is the acronym of Sensor Network for Intelligent Predictive Enterprise. And this is the web page where you can find some information about the project and where we will put all the updates of the project. The consortium is made by 3 companies. My company is FAE Technology. We are an Italian SME. We work in design, engineering of electronic boards and IoT devices for several market sectors. We have Arizzi Fonderie is our end user for the demonstration. They are a cast and iron foundry, also an SME based in Bergamo, so in Italy. And we have Chilometro Rosso, that is the innovation district based between Bergamo and Milan area, that will take care of the communication and dissemination aspects. First of all, we start from the scenario of foundry and casting. We are in a part of Italy that is quite famous for being one of the most European advanced area for the foundry and casting. This competitive scenario is characterized by some features. For example, the increasing request for energy efficiency and the stronger emission regulation. It is a market segment where the traditional maintenance methods are still in use, and the traditional time-based maintenance it's still applied on some key production processes where there are some preset timeline to make some important maintenance operation. Moreover, the switch to digital transformation and Industry 4.0 require, in some cases, high investment to substitute or upgrade the machine in an industry where normally there is an average long life service of the machine. So imagining a melting furnace, for example, it is not something that all the companies can change or substitute without making a big investment in terms of money. Also, machine downtime in this specific production process has two big impacts. The first impact that is quite understandable is the decrease of the productivity level, the increase of the process instability, and also the complexity to restore the correct working situation when a problem appears during the production cycle. And the second one is the energy waste, considering that in all the cases where there is a problem alongside all the production chain, you still have big energy consumption in the process that is the melting process that is, let's say, at the top of this production chain. So the project overview is that we will create a demonstrator with based on an artificial intelligence IoT network system for a machinery revamping in foundries to have a real-time monitoring of production processes and enable predictive maintenance on some critical production phases. We will create a modular smart monitoring infrastructure based on some IoT sensor boards to collect process data, so temperature, engine vibration, microphone, humidity, and everything will be managed to predict maintenance on critical processes, and so improve and increase the OEE of the production process. Cybersecurity is also a fundamental element of the architecture that we are constructing. When the whole production plant is cloud connected, of course there are cybercrime and hacking problems so can appear, and therefore we will have a dedicated activity focused on the implementation of a cybersecurity approach end-to-end from the sensor arriving to the cloud. The focus of the project will be to demonstrate the effectiveness of this IoT revamping solution, specifically on three key processes of the foundry, which are common critical processes for all the foundry in the industry. And they are the melting process, the conveyor and belt transfer, and the grind sand production. These are the three most critical processes because they have a big impact in terms of energy consumption and economic impact for the company that are managing problems and failure in these processes. Together, we will create also a wearable demonstrator of a smart device that will be an add-on to this IoT network to deliver some basic information to workers and operators in this harsh environment in case of machine fault or process problems. So the scope will be to transfer some easy information through LED, through vibration and haptic motors to the worker of the foundry. Just a quick technical breakdown of what will be used and what will be implemented in the demonstrator. We will design through parallel activities and we will implement a sensor network based on custom sensor IoT nodes, collecting data and parameters from the field, so vibration, gyroscope. We will have an evaluation board dedicated to detect the belt thickness, humidity level in some specific area which are quite critical, and the energy consumption of the melting process. This demo unit of wearable device. We will have, of course, an IoT gateway that is a product that is in our product line, so has been developed and produced by FAE Technology with a multi-protocol to be able to collect the data from the sensor and transfer the data to the cloud platform. We will have a cloud dashboard. We will have the AI algorithm, so a custom algorithm to enable prognostic maintenance in some specific part of the process. And of course, we will have the cybersecurity that will be end-to-end. So there will be some specific cryptographic elements that will be added to the sensor network to provide a secure data transfer between all the components of the sensor network. The key benefits that we expect to achieve through the implementation of our demonstrator are a reduction of downtime, specifically for the melting process through a real-time monitoring of energy consumption, a reduction of downtime in the conveyor and belt transfer for the movement of the manufactured goods and the green sand, and the prevention of, so improvement of production quality through a real-time control of the green sand humidity level, which is a critical parameter that in case of bad condition of the humidity of the green sand could create some cracks, inner cracks in the final manufactured good. Considering in general what happens for the foundry and casting market, we think that this revamping approach to the digital transformation can be a good solution, considering that this industry is an industry where almost 70% of the companies are small enterprises with less than 50 employees. Therefore, with a limited access in terms of technology and also in terms of investment, to have the possibility to benefit the real benefits of Industry 4.0 approach. Therefore, we expect that to be able to show the advantages of a revamping approach could be a very good solution. Just the last slide to resume the consortium partner, which I already explained. So we are a technology end-to-end provider for the IoT application. We have the end user company, and we have in the consortium Chilometro Rosso that will manage all the communication and dissemination activities for the project. I guess this was my last slide. So yeah, that's all from my side. If you have any question or
Yes, thank you very much, Manuel, for the presentation. Any questions? There was one question. Check. How you send cloud platforms?
yeah.
Maybe it's you support different cloud platforms, was the question. And how open is the system? There are two separate questions here.
Well, two good questions. Let's say the cloud platform that we will use will be based on Amazon AWS, and it's a cloud platform that is made by one of our let's say ecosystem partner in the IoT development. So they will give us for free the access to the platform infrastructure that they already created, and it's based on Amazon AWS. Generally speaking, the system is made, all the data are transferred through MQTT protocol from the gateway to the cloud. So MQTT is a quite standard protocol that is used in almost all the cloud providers. So this communication between gateway and cloud can be applied to 20 cloud. So you can use Microsoft Azure, just to give some names, or whatever uses this kind of communication protocol. The complete system will be based on some boards that we have developed during the last years. Some of them are the technical features are available on GitHub, so the documentation is open. For the IoT gateway, it's the same. So we have a GitHub page where we have all the technical documentation of the gateway. So let's say the system is quite open, and everything is shared. I don't know if I replied to the questions.
Yes, thank you, Manuel. I think that answered it. It was mostly about third-party development and how open, but there's no new questions coming. So are you using also a middleware? And then there was a request that if the GitHub link could be placed on the chat.
Yes. So for the link, maybe I can, well, if anyone is interested, maybe because I need to check and find the link, maybe I can share through email, or if they can write to me an email to my email address, I can share all the information to the persons that are interested. I don't remember the first question.
Yes, are you using also a middleware? Was the other question. But for the GitHub link, please contact Manuel directly with email. You see it on the screen. Yes, the unanswered question was: are you using also a middleware?
Yes, let's say we are using, as I said, the data will be transferred to this cloud-based solution, where we will have a middleware for data retention and data storage, and then the data will be transferred to a dashboard that will show the data captured by the sensor, and in the dashboard there will be also the part of predictive maintenance algorithm that will make the analysis to make the prognostic on some specific parameters and data.
Good, thank you. Any other questions to Manuel on the SNIPE project? Are you using the analysis results on the factory floor?
Yes. So I try to
follow-up question that is the process reactive? So I guess the question is that are you sort of tuning the process based on these analysis results?
Yes. In fact, we started from the need of the user. That is a real need based on their how to say Pareto analysis of main defects in their production line, and we will tune the effectiveness of our solution together with the end user, analyzing the data and checking the real effect in their production floor. So everything will be managed directly inside the factory.
Okay, thank you very much. And then one final question. Is the AI done in real time in the cloud or on the edge?
This is a good question. At the beginning, I think the approach will be to be done in the cloud, but we are thinking to move some pre-analysis also on the edge, and specifically on the gateway. The gateway is powered by a CPU, while the sensors are in most of the case based on microcontrollers, so with a limited capacity of making machine learning and AI analysis. So probably something will be made also on the edge, but at the beginning we expect to get the AI mainly based on the cloud.
Good. Thank you very much, Manuel. It's a very interesting topic, all these cloud-based IoT systems, and clearly that can be seen on the active discussion and questions. And if you have any further inquiries, you can contact Manuel directly. But now we need to move on to the next presentation. So next one will be more on the focus on easy use and modular solutions. So this one is given by Thomas Rønløv, who is the CEO of ROBOBEND in Denmark. And just a second, I will bring. So ROBOBEND is working on a standardized robot work cell that could replace the human operators in bench press tending. So basically a machine tending application for the bench presses and sheet metal working. But let's let Thomas talk and explain more on what they are working on. Okay, go ahead, Thomas.
Thank you. So I will find the presentation here. So thank you very much. as mentioned, the ROBOBEND, that is a world's first standard bending robot. And on our team, Trinity team, ROBOBEND is the leading company, the leading tech company of the team in this Trinity project. But with us, we also have BCM Transtech, that is our SME case, and which provides the inputs and where we'll do the demonstration. They do warehousing, sophisticated warehousing systems, and then we also have our good partners from Robot Nordic that is also assisting us on certain parts of the technology development. And as mentioned, the ROBOBEND is the new machine operator. So it's basically the first standard bending robot, which means that it can control approximate 1.5 million press brakes that exist around in the sheet metal industry in the world. So it provides high uptime and higher capacity of existing machines, which means that we can use existing machines at a higher capacity with the same high quality every time, using very simple programming that is both easy to use and easy to maneuver with, and then as a standard solution delivers short payback time. But why at all to automate the bending process? Well, there is lack of machine operators, which means that the companies finds it more and more difficult actually to have the capacity in-house, which is a growth killer if they are planning to grow their company. And it's because it's really to be a machine operator at a press brake or a bending machine is repeatable and then very dirty work. So that is why it's not really attractive to be a machine operator. But when they are developing both a flexible and mobile robot, it will be possible to make it a good business case than to do it automatically instead. The business case can of course be calculated based on many different factors. In Denmark, as an example, with 2 shifts, and then depending a little on how much you have new items, how much you are using the existing items. The idea is that our robot should at least be able to make savings of 140,000 euros a year. So here you have a scheme, you can say, of the initial prototype that we have made, and then where the idea is that during this Trinity project, they should be able to produce items up to 1.5 meters, that we are reducing significantly the changeover time. So when you are shifting from one project to the next, so that should take maximum a few minutes. And then even when you do the programming, up to 20 minutes. And the programming is supposed to convert the drawings, the XF drawings, into both a program for the robot, but also a program to the press brake that the robot cell is controlling, and to reduce the cycle time so that one bend takes approximately, depending on the complexity, but approximately maximum 15 seconds, which means that the overall here will be at least as fast as if it was a manual operator, and then we have a much higher capacity at the same time. So the robot should be consisting of a feeder where you place the items, and from where the robot on a rail system is picking up the pieces unit, putting it into the machine, and again the robot cell is controlling the machine, and then put over in the collector, either on pallets or on boxes, depending on the need and the wish, and with a coupling system that enables us to be mobile, so that you can remove parts of the robot from the press brake and do production manually if need be. So the brain, part of the brain of the system is what we call RBMI, and then which is crucial important, the robot bending machine interface, which is the controlling unit, which is made in such a way that we will be able to control most of the press brake. So that means that we are capable in converting drawings into the programs for both the robot and then for the press brake machine, and afterwards to fully control the press brake machine, make the machine the slave of the robot, so to speak. And the other part is our user interface that we are working on as part of the program as well, where we are working on this converting of the drawings to the programs. So in one way, quite sophisticated the software system, but should still be quite simple to use, where you have the engineer that is doing the programming. He can be sitting up in the office, and then the operator that goes down and then they puts in the items for the next batch. That is very easy for him to check up. Do I have the right tooling? Do I have the right amount of pieces? And the right pieces are placed the right place. And then 200 pieces, press start, and then he can start up the robot, which again is a very important part of making the good business case, and then enabling us through this TRINITY program to transfer this primitive prototype that we have made into a real market ready product that is both flexible and then capable in working with both small and big items, and in this way being able to automate most of these 1.5 million press brakes that is placed around in the sheet metal industry in the world. And if more information is wished, then you're welcome to contact me like this.
Thank you very much, Thomas, for this presentation. Any questions to Thomas on the ROBOBEND project? There is one question. What is the precision and payload of the bending robot?
Yeah, so what we are, if we talk about the precision, then we are talking about basically we will be able to get almost down to the precision of the robot arm, which is a FANUC robot arm. So there we're talking about plus minus 0.1 millimeter. So this is the precision, and the payload will be most probably up to 20 kilos, although that is not what we have promised in this application, but we are actually trying to even be able to work with larger items and up to 20 kilos.
Okay, and there's a follow-up question on what kind of plates can be used.
What kind of plates?
What kind of plate, thickness and type?
So basically, the thickness is it doesn't matter. It's basically the matter of the press brake that you have. So what is important is that they are not so large that they cannot fit into the feeding system, and that we are not exceeding the payload. But basically the thickness does not matter.
Okay, thank you. And there's another question. If needs to change the bending tools as the matrix, are there automated tools?
It's not automated in this first version. We have thoughts on how to do this as well. But what we have learned from developing robotics that you have to do it step by step. So this would add quite some complexity. So this is not in the first version, but it is thought in, as well as it's thought in later on with the way that we do the feeding, that it should be able to deliver pieces with a robot from the machines to our robot, doing the bending, and then picking it up afterwards with a robot. So there is certain things that is being thought into the design of the robot, which will be solutions and functionalities that we will only be working on afterwards.
Okay, thank you. I think that answered the question. Any other questions? The monitoring system, will it include performance monitoring?
It depends on what you call a performance monitoring, but yes, if we're talking about the ability of following, if you are actually following the production program, when you when you have started, when you have produced the items, when you have started up on the next orders, etc. So this part of the performance, we will be able to deliver information about. Yes.
Yes. So basically, the uptime, that was the question, that can be also monitored.
Yes. Yes. Exactly.
Okay. Any other questions to Thomas? I see you are using a so-called standard industrial robots, not the collaborative robots, which are quite trendy at the moment. So
Yes.
what are the main reasons you are not using the collaborative robot in this application?
Yeah, you can say maybe we should look at what will be in the future. But when we started planning it up, collaborative robot arms was mainly universal robot arms, and then we think they are simply not the fit for these. You should think about that the robot arm is working all the time and lifting quite heavy pieces. So it simply needs to be very strong and precise robot arm that we are using, and we decided that the FANUC solution for us was the best solution. And the way that we have built up the robot, then we are kind of covering the robot arm, so it will not be possible to get close to neither the press brake nor the robot arm when it's working. When you, for example, then have to place pieces, or if you have to collect pieces, then the cell will know that there is some interference happening, and then it will stop. So in this way, we are making it safe without that we have to have a safety net around it, because the robot and the design of the robot actually makes up the safety net, and then we are getting a strong industry robot that we feel is required here.
Yes, thank you. Very good points there. It's and something that is forgotten quite often, that even if the robots might be safe, the application not necessarily is, especially now that you are handling sharp and heavy objects. So
Yes.
I think it's a wise decision not to go with the collaborative robots, because I think their possibilities would not add anything into this solution. So I think it's a very good reminder that you don't always need to use a collaborative robot, especially in 24/7 applications where we have very little information how robust these new robots are after all.
Yeah, exactly.
Okay, thank you very much, Thomas. If there is any follow-up questions, you can email them to Thomas, and also all the presenters, you can check the chat window, and if you think there is some unanswered questions, you can also answer those to the chat, and then get the contacts of the people interested, and hopefully communicate also in the future. But now let's move forward. So our next talk will go to the collaborative robotics thematics, which has a lot of applications, especially when we go into the lighter activities and handling cases. And this new project in Trinity, DigiSub, is focusing on one application that is quite interesting from the collaborative robotics point of view, which is screwing, and how to make a screwing tool to be sort of a plug-and-play tool for collaborative robots. So Thomas Sörlund, CTO of SNIPE Robotics, will be presenting this case. Go ahead.
Thank you very much. I will share my screen. So 2 seconds. Can you all see my screen?
Yes.
Yes. Okay. Thank you very much. My name is Thomas Sörlund, and I'm the CTO of a Danish company, SNIPE Robotics, situated in the Odense, the collaborative city of Denmark. We are focusing on screwdriving applications for collaborative robots. So the project DigiSub is a collaboration between 3 companies, us, SNIPE Robotics, and TRINITY.io, which are making cloud-based systems for data logging. And then Elvis, a Slovenian production company working in the automotive industry and assembling a lot of screws. So that's the consortium. Our main focus of the project is three folded. It's one, introducing the first end-of-arm screwdriver tools for collaborative robots for mounting 1 to 6 millimeter screws. It's integrating Industry 4.0 quality technology to increase the process quality, like torque and angle control of the process, and then make a tool for visualization and data analytics in the cloud, so we can keep the good quality of the assembly process. So our mission and why are we doing this project and working in this domain is that today we have a lot of manual and repetitive tasks in industrial assembly of especially screws, bolts, and nuts. So what we want to do was to introduce the first screwdriving tool that is fitted for collaborative robots, and then we will want to put a quality assessment system on top, so we also know that the screws is mounted correctly. So why are we doing it? Today, millions of screws are mounted manually with handheld screws, drivers like on the picture. Typically, if you take a stopwatch and look at the time used, then it's up to 40 to 50% of the assembly time is used for screwdriving. The rest of it is handling other objects in the assembly process. It is highly repetitive, so it's high risk of injuries and of wrist, elbows, and shoulders. The return of investment is not very good. So what we saw was that we actually needed an end-of-arm tool for screwdriving applications that was both easy to use but also safe, because we couldn't see that there was any safe screwdriving tools at that point. So our solution is a screwdriving tool with a small controller box where we have an embedded web server for data exchange, for machine-to-machine communication. We have also a cloud interface to store the data. Because this is a tool for collaborative robots, we have started by making a URCAP for universal robots, but we have introduced the SPIN controller box in order to be able to interface to different cobot brains. So this is a tool for ready to ship to end robot integrators, where they can use it for their machinery. So what's the benefit of this? Yeah, we introduce a shorter return of investment by having a standard tool. We introduce plug and produce. We have a safety shield in the screwdriver tool, so the screws are never exposed to humans during the process, so it's safe. And then in this project, we will try to introduce this online quality assessment of each assembly process. So monitoring if we are increasing and if we're getting the right torque. So the use case in the TRINITY project is together with a Slovenian company, Elvis, and they making heat lamps for the automotive industry, Audi, Skoda, and a lot of other companies. And they have a lot of screwdriving process in that when they are producing these. And another thing that makes automating screwdriving process a benefit for them is that they need to deliver parts in 15 years. So they need to have a lot of that they can produce. This requires some flexibility in the production and robotic setup. So the TRINITY demonstrator, it's a simple cobot application with fixtures, and then our platform for both the tools and for programming the robot, and a small controller in the small controller box to collecting the data from the screwdriving tool. So our approach on the Industry 4.0 is to have our control box, which includes a machine-to-machine interface where you can get the data from each screw insertion out if you want to use them on the factory floor. So you can use protocols like Modbus TCP, OPC UART, or MT Connect to get the tools out of the box. Then we have also we'll work on the cloud solution made by TRINITY, where we will push data to the cloud and visualize it. From that cloud, we will go to a Google cloud platform where we will train models for detecting failures in the assembly process. And these trained models will be deployed to our platform afterwards to make online inference each time a fluid is assembled. So this was a little bit about the project, which focus on developing our tool and then doing this platform. So thank you very much for your time. And if you have any question, please come with them.
Yes, thank you very much, Thomas. There is already a couple of questions in the chat window. So there is a couple of questions. What are you using as a Industry 4.0 connection? And then follow up, are you using an Industry 4.0 framework?
We are using the framework by our partner TRINITY at the moment to push data. If that was the question about when you were speaking of frameworks, and that framework is using some of the Industry 4.0 protocols to push data to the cloud. I think I maybe was it the question?
Yes.
Or?
So it was
okay.
Connection and the framework. So I hope that answered the question, but they can be.
Yeah. So many of the protocols is MQTT. The cybersecurity part is SSL certificates to make it secure. But that platform, that's our TRINITY partners that have created that for pushing data. So we are using that for pushing data to the cloud and visualize it in the cloud. We would like to create a platform in the future where we have not only one tool on this platform, but have many different tools, have many tools in. So if you have one factory that have 10 of these screwdriving platforms, then the cloud platform will collect the data and give you the overall view of how this is working and running in your production on day-to-day basis. Yeah.
Okay, thank you very much. And then a very interesting question that I could have asked myself so explicitly: how do you ensure the safety? What are the safety elements?
Yeah, I can explain it very well. In the tool, I will just go back very shortly. In the tool, we have a safety shield, this yellow one. It is on an actuator. So whenever we are taking a screw in a screw feeder, this safety shield is moved down to the screw, so it's not exposed anymore. If the tool is going down to your hand or arm during an assembly, there are a safety sensor in the tool that will be switched off, and then it will turn off the robot and the motor in the tool. So our tool is safety certified according to TS 15066. So it's not increasing the forces that are defined in that standard. So if you are unlucky and put your hands underneath the tool, it will actually not give larger forces than is in the standards. So we have a performance level D sensor embedded in the tool, so it is industrial safe.
Okay, good, thanks you. That answers the question, yes, because otherwise the sensitivity of the robot and then the sharp screws would definitely cause too high surface pressures for this kind of application.
And I can just briefly tell that the tool is actually have an embedded compliance, so it can be moved in the joint with this where it's connected to the robot. So there are actually a mechanical actuator on it, so you can actually move it up and down. So if your hand is in pressure underneath the tool, you can actually physically take the tool and lift it 1 centimeter and take away your hand again. So there are mechanical parts in the tool that makes it possible to get out of a hazard if that's happening.
Okay, thank you. So then there's a question, 2 questions. I think we take these and then we move to the next one. So first one, talking about Industry 4.0 framework, can this system integrated with other machines and systems using similar Industry 4.0 framework? It's about interoperability. So can it connect with systems?
So I guess you are thinking of, is it other cloud systems or is it more machine-to-machine systems? Because if it's Amazon or Microsoft Azure IoT hub, then we haven't implemented it yet, but that's a part of this project to implement MQTT connectors, for instance, to push data to, for instance, Azure IoT hub. So it will be possible, but that's also why we are participating in this project, is to work on this part as well, to push the data. So in the end, the data is actually a torque time curve. So it's a 2D curve that gives the profile of when the screws are turning and mounted. It starts increasing the torque, and so it's this curve that we actually want to detect failures on, but also use for the quality control part. I don't know if that answered the question.
I guess there can be a follow-up in a chat, and you can answer it there or be in contact with the person. But basically, I think the final one, it's more of a comment from our cybersecurity specialist in the TRINITY Consortium. So cybersecurity is more than transmission security. There are a couple of challenges in this and the previous application that would need to be hardened. We can provide support through TRINITY Ask Your Mentor for a meeting discussion. That's, I guess, something that we have this now available. So I think that would be contacted with Ulrich Seldeslachs, and then you can discuss on these topics. So that
we'll be open to that, and I think Lars from Tintlock will be very interested in that as well, because yes, you have than just transmission security. But our focus, I know that we have this issue of cybersecurity, but our focus is also to get it out there and work as a start. And we believe that the TLS is a start. But of course, we need to be aware of the next step, and we would very much like to discuss that with Ulrich of what could be done to make it even more safe.
Okay, excellent. Thank you very much, Thomas. So now we can move on to the last presentation of today. So now we have a talk from My Way for Robotics Consortium given by Fabrizio Cardinali, who is the CEO of Knowheads in Italy. And basically what they are working on is combining robotics, AI, and different IoT topics. And this is about predictive maintenance for the robotics and other automation devices. But let's have Fabrizio talking about their solution for this topic.
Okay, are you seeing the screen?
Yes.
Okay, thank you for the handover. I'm Fabrizio Cardinali. I'm the CEO of Knowheads, which is a consulting company specialized in distributed ledger technologies and blockchains, AI at the edge, shallow AI, and IoT technologies integration. We have developed this proposal together with the University of Genoa, with Professor Fulvio Mastrogiovanni, head of the EMRO lab inside the University of Genoa, and with an external system integrator named Zenatech. The idea is that to develop a servitization platform or equipment as a service platform for robots maintenance. The concept of servitization is gaining a lot of interest in the manufacturing market today. It's a concept which has been out since the early age of manufacturing from Mr. Ford, when he actually did the Model T first car. And the idea was actually not to sell products, but to sell services. And this in order to increase the financial outcome so that you can switch from CapEx to OpEx cost to increase maintenance and operational outcome, and to make the customers happy. This is now affecting a lot of products and manufacturing goods from less sophisticated to more sophisticated ones. We're working with turbines, with large laces, or even with consumer goods or biomed equipment. But the idea of this project is to apply it to robotics, maintenance, and servitization. The pandemics have been a big game changer, which is accelerating the go-to services for all the product lines and for a lot of fields. Essentially because to the commercial needs of servitization, there is now an operational additional need, which is that of maintaining the critical uptime of the equipment, to keep the social distancing of maintainers, which can no longer go to the physical location to perform maintenance, and last but not least, to have privacy and security by design, so that all critical information is actually maintained in the ownership of the user and or let's say business owner of the setup. And this is actually exploding with the pandemics, because it's obviously coming from biomed and medtech, but going in all the sectors. End users are very happy of this trend. This is a study from Salesforce, which is available at the link here under, where not only 69% of consumers, but also 82% of the B2B market is going towards servitization. And this important data here says that those who are using AI, blockchain, and IoT in an innovative way are 2.1 times more likely to be the leaders of the future of manufacturing production. The Troy horse for getting in is maintenance and prognostic maintenance services. As you see here, 71% have declared that they are doing it while we are talking, and 28% of the interviewees are saying that they are going to do a prognostic solution for their equipments. But then once you are in as a Troy horse, adding cybersecurity services, insurtech services like giving warranties on a more tailored way, or even fintech services like pay-per-use or a factoring of the payments of a robot, up to forensic of if you have done the warranty and the maintenance at the right moment, is going to be killer applications and killer services for making service happen. So the idea here is to start from prognostic maintenance, where prognostic is applying AI at the edge for detecting anomalies, incipient failure, and the remaining useful life of a robot by doing edge computation. But the idea is then to add our services. To do this, we need a platform which is able to monitor the robots, is able to transmit IoT streams of very large data coming from sensors, either embedded or into retrofitted industrial arms, which don't have sensors, to store in time series or even binary large objects on files, and then to analyze them either at the edge, in the fog, or on the cloud, and eventually to certify on blockchain the outcomes. So this is actually the technology we are developing. It's patent approved now. It was pending when we submitted. Now it's been approved. And it's actually having an edge gateway where you act the streaming coming from the field. And then you have an AI infrastructure with shallow learning, very important approach to AI for doing this. And then you have a DLT or a blockchain to certify if you have any fault or a missed warranty or maintenance procedure, with all the interfaces needed for doing that. This is the streaming part, which needs to have FPGA and on the edge pre-processing of digital signal processing with sensors like the Bluecoin from ST, or the XDK from Bosch, or a Ruvitag, which is a cheaper one. So we are interfacing sensors with XYZ, and even rumors for audio detection for vibrational analysis. Then we have our own edge computer, which is the patented one, where you can even call voice control, so that the maintainer can ask to do specific routines to the robot to get it tested and evaluated. The AI I cannot deepen with the short limit, but it's a complete different approach than deep learning or traditional machine learning with huge data. It's using much more smaller data at the edge, and it uses even just a couple of hundreds of information about the correct performance of the robot to create an artificial neural network and to detect anomalies. And this is actually chip-based, so it's light speed at the edge. And then we have this DLT, which is the IOTA DLT, which is a leading European new topology of a blockchain, or let's say a variation of blockchain. It's actually a tangle where you have a mesh of robots and edge computers connected. And it also uses a peer-to-peer infrastructure like the interplanetary file system to store eventually data series or time series where you detect anomalies. This is it. If you have any questions, I'm more than happy to take them.
Thank you very much, Fabrizio. So, any questions on this topic?
Yes, it's more a compliment than a question. I see amazing, a complete solution. Yes, it's an end-to-end. The idea is mostly to, I mean, everybody's got IoT platforms. There are more than 800 out there. The idea of my way for robotics is to tailor it for servitization and to have data streams from connected things. A thing could be a turbine from Ansaldo, which is one of our customers, could be as an ecography from the Esaote offering, which is another of our customers, or eventually it could be a robot. We are piloting it with a Comau smart NSI6 robot, which is an old Industry 4 robot, so retrofitting of existing workflow robots, or new ones like the Franca Emica Panda, or most likely the Strobli product series, because we have a pilot in automotive field where they are using Strobli robot arms.
Okay, so you mentioned that there's a pilot coming. So will that be in this Trinity project, and when can the audience expect to see some results or examples of the technology? Do you have plans for that? Fabrizio, did we lose your voice? Apparently, I think we lost the connection somehow, because at least to me, I don't hear Fabrizio. But others, do you hear my voice still?
Yes, loud and clear.
Okay, brilliant. So I guess there is something with the connection from Fabrizio's end. But so I think we need to move the questions and answers to email, so you can contact Fabrizio for the more questions, and I will bring it up. So here is the contact information to My Way for Robotics project. So thank you very much, Fabrizio. Very interesting technology, and we are waiting for nice demonstrations by the end of the Trinity demonstration program. And so this basically concludes our second webinar. And
yes. Sorry, the line went down. I understood you were asking about the pilot.
Yes, go ahead.
Sorry for that. So we have two pilots, actually. First, an internal one with University of Genoa, and the Comau robot arm is inside the labs of the university, so that will ease the setup, and one that is going to work, we will move into a real life pilot beginning of next year. It's an automotive, it's a European leading firm doing all the plastic prints inside important cars like the Porsche or the Audis, Volkswagens. It's named the Series Studio. It's the leading company doing all the cockpit printing of the plastics inside or the materials inside the cars.
Okay.
And they have a strobely line with 5 or 6 arms to do the pressing.
Okay, excellent. That sounds very interesting. Looking forward for the demonstration. Thank you, Fabrizio, for this. And
sorry for the line went down exactly.
No problem. No problem. Thank you very much also to all the speakers of today and the audience. I think we had a very nice and active discussion on this topic. So as mentioned, we will place the recording on our YouTube channel. So there you can go back to the topic if there was something interesting you would like to learn again. And you can also, of course, forward these links to other interested parties. So we are now on the halfway of our webinar series. So there is 2 webinars to come next Monday and next Wednesday, when we focus on different computer and machine vision applications, and then human-robot collaboration and mobile robotics. So other interesting technologies that can clearly improve the agility of any manufacturing and also SMEs. So for this, you find the information on our website. And here are once again all the contact information. So please do follow our social media channels, be in contact if you have anything to ask. And then check our coming second open call if you have a good idea that could improve the agility of manufacturing. Please do apply for our funding for the second round when we open it next year. But without further talk, thank you very much for taking part. And if you still have comments or feedback or suggestions, please do write to the chat window. But I hear from you and see you, or at least feel you, on next Monday in the coming session. Thank you very much. Bye-bye.